Yeah, good morning, students.
Good morning, sir.
Good morning. Right. Is it visible?
Yes, sir.
Yeah, good. Okay, right. So, welcome back. Now, we'll proceed further. Now, last class yesterday, okay, I just completed what was called as the optical encoder, with which we have finished the different types of the transducers. And then we'll move on to the second chapter, which is microprocessor and microcontrollers. Okay, right. Now, the flow of the chapter is like that. In the first chapter, you are discussed about introduction to the mechatronics, followed by the transducers and sensors. Okay, now, if you can remember the first class, the first or the second class that we have discussed, for any mechatronic system, in any mechatronic system, broadly, there will be three different components which are going to be present. Okay, can anybody say which are those components? Can you able to remember and tell? There are some three broad components are going to be present to define a or to make the mechatronic system to function. Can I have your observation for this? The first one is to sense the outside environment. The second one is to make the decision. The third one is to implement the decision. Correct. So these are the three things that has to be done. Okay, in a mechatronic system. The first one was the system or the device which is used to perceive the outside environment or understand the outside environment. Okay, which was done by a system called as a device called as. What is the device which perceive the outside environment?
External sensor, sir.
Sensors and
Sensors.
transducers. Okay, sensors and transducers. Okay, that was the first thing that was covered already. The second one was based on the information obtained from the sensors or the transducer. You need to make certain decision. Means some device has to make certain decision. So decision making device. So those decision making device are called as quickly. Are called as what?
Controllers.
Controllers. Very good. Okay, those are called as the controllers. Then third one, so controllers has made the decision. Therefore, some other device has to be there to in order to implement that particular decision. So that implementing device is going to be called as
Actuators.
actuators. Good. Okay, right. So these are the three elements. That is sensors slash transducers, controllers, and the actuators. The whole of this mechatronic subject will be around this particular three different elements. So the sensors and transducers we are done with. Now we'll move on to the second module. The second module says about microprocessor and microcontrollers. Okay, basically microprocessor and microcontroller. This module is completely related with that of the device which is responsible to make the decision. Okay, so the decision making element of your of your mechatronics control system or the mechatronic system is microprocessor and subsequently microcontrollers. Still you have a better of the controllers called as your the programmable logic controllers, and still there are other the devices are going to be there, but this module is mainly deals with microprocessor and microcontrollers. Okay, right. What are we going to study here is broadly this. So microprocessor or microcontroller, we'll go with the study of the introduction. Then microprocessor system. What do you mean by microprocessor system? The broad understanding of microprocessor system. Then basic elements of a control system. Then we'll try to understand what are microcontrollers, differences between microprocessor and microcontrollers. Then architecture of the microprocessor. In the microprocessor architecture, we are going to discuss the individual terminologies like CPU, memory, and address, input I/O devices or the input-output devices, arithmetic logic unit, what are instructions and program, what do you mean by assembler, what do you mean by data, what are registers, PC, program counter, flag, fetch cycle, write cycle, state, bus, interrupts, something like this. Okay, so these are all the things that what we are going to discuss actually. Okay, Right. Now, well, before we go further with this the detailed discussion, now let us start with the introduction to the microprocessor. Okay, right. When we just go with the introduction to the microprocessor, I'll just have some thing now. Okay, we'll just discuss, and then I'll switch over to the PPT mode. Okay, right. So now we are going with okay, right. So microprocessors. Okay, right. Now, what are microprocessors? Let's understand some introduction of this. Yeah, what are microprocessor basically? Yeah, quickly. What role it plays? What role the microprocessor is going to play is important. Okay, right? The microprocessor, as I said, so they are going to be the controllers. Okay, the controllers which are the decision making device. Okay, which are the decision making device. Okay, I'll just write, or I am writing all this just for you to make a quick write up on the contents that I am going to write. Okay, it is always better. So just note down the points. Okay, I'm not giving notes, or I'm not dictating anything. So please make sure that the points that I'm going to write, you just write down for a quick reference later. Okay, right. Now, now basically, the microprocessor is going to generally used in any industrialized environment. Okay, it is generally considered as a logic device, or a programmable logic device. Okay, it's considered as a programmable logic device. Okay, so which is going to be mainly used, okay, to control the processes. Okay, which is mainly used to control the processes. Okay, when I am going to use, it is mainly used to control the processes. In order to control the process, I am going to have what are going to be called as the set of instructions to be present. Okay, I should supposed to have what are called as the set of instructions which has to be fed into this device, or the controller device, and this set of instruction is what we termed as what are called as the programs. Okay, now when I say about the controlling the processes, now controlling the processes is mainly because that we expect the mechatronics device to perform in a predetermined manner. Okay, because of the concept of your closed loop control system, we expect the controlled, sorry, the mechatronics device to perform in a predetermined form. Therefore, the controlling of the process is going to be very important. Okay, and in order to control the process, this microprocessor should also supposed to do what is called as the computing activities. Okay, so the microprocessor should also supposed to do what are called as the computing activities. Okay, so it does the computing activities based on the calculation, or based on the work that it has done in the computing activities. It is also going to be used as what is called as a decision making unit. Okay, so based on the computation that it has done, it gives you, or it makes the decision. Okay, therefore, now when I want to say the computing activities, okay, so prior to this, it should also be done what? Okay, it should also have the collection of the data, and it should also act as what is called as a data processor. Okay, means to say the microprocessor. Okay, the microprocessor is going to be broadly considered as it plays a major role in the functioning of the industrialized environment. It is considered as a programmable logic device, which is mainly used to control the processes. So the controlling the processes is going to be done by through a set of the instructions that we have fed to the microprocessor chip, which is called as a program. And basically, this microprocessor is also going to be called as it's a data processor, and which does the computing activities, and also a decision making capability. Okay, right. Now, basically the microprocessor, okay, so generally we know this is the thing what we use. So microprocessor is going to be called as the central processing unit. Okay, so you can understand the generally microprocessors are going to be called as a central processing unit. Okay, built on okay, so central processing unit built on a single chip. Okay, so built on a single chip. So single chip central processing unit are going to be called as the microprocessors. Okay, now this is what is the basic understanding of what is called as the microprocessor. Okay, Now, in this case, now what are all the other activities that it can able to do? Okay, basically, a microprocessor is what is called as a multi-purpose. Okay. Now, unlike there is one more constituent here, which is called as a microcontroller. Okay, that we can discuss later. Microcontroller is not a multi-purpose functional element. Basically, microcontroller is a specific purpose. Okay, it mainly used to do a specific purpose. Okay, unlike the microcontroller, microprocessor is going to be used for multi-purpose operation. Okay, you can make use of the microprocessor in order to do the arithmetic, logical, and all the other operations. Okay, microprocessor is a multi-purpose. It's a programmable. Okay, it's a programmable. Okay, and a clock driven. Okay, so clock driven is for the time based activities. Okay, microprocessor is a multi-purpose device, programmable device, and a clock driven device, and register based. Okay, now we'll discuss all this. So register based. Okay, register is nothing but to store the information in the microprocessor. We are going to use what are called as the register. Okay, register based a device. Okay, register based device. Okay, now what information it is going to read? Okay, is it going to read a decimal data or a binary instructions? Microprocessor is a digital device. Okay, which is going to be mainly reads what is called as the binary information. Okay, so it reads binary information, okay, from a storage device. Okay, so binary information from a storage device. That storage device, it is called as the memory. Okay, right? And it accepts the binary data. Okay, now if I consider the microprocessor, it accepts the binary data as the input, that is 0 or 1. Okay, processes this data. Okay, processes the data and gives a corresponding output. Okay, now this is basically broadly the basic concept of your microprocessor. That means microprocessor is what? It's a programmable integrated device. Okay, it's a programmable integrated device which is having the computational capability and also the decision making capability. Okay, so the computing activities also, and also decision making activity also. Okay, and also the microprocessor is one more thing. It is a CPU built on a single chip, is called as a microprocessor, which is a multi-purpose programmable clock driven register based devices which takes the input in the form of binary data from a device called as memory, processes those information and gives a corresponding output. Okay, right. Now this is something related to what is called as the microprocessor. Okay, so now what are the specifications of a microprocessor? Okay, now we say 8085 microprocessor. Okay, 8086. Now if you go with what is called as microcontroller, you have 8051 at chip controller. Okay, right, so on and so forth. Okay, there are different ways by which you are going to name the microprocessor. Okay, generally the microprocessors are going to be specified by what? Specified by the total number of bit it can able to handle for data processing and the speed of the operations. Okay, so that is the basic thing. Now just with this the basic information, okay, of the microprocessor. Okay, I'll just proceed further. Okay, with what is called as the microprocessor system. Okay, so sorry. Okay, we'll go for what is called as microprocessor. Microprocessor system. Okay. One second, please. Okay, right. So microprocessor system. Now we'll just have a small block diagram. We just want you to just make a small block diagram. Please note down. Okay. Input output device. IO devices. Okay, right. Now, okay, right. Okay, right. Now, let's understand what is the formal structure. Now, this whatever I am writing is the formal structure, okay, formal structure of a microprocessor system. Okay, so whatever I am telling is the formal structure of a microprocessor system. So basically, it consists of what are called as the microprocessor. Second one is what is called as I bar O, that is input and output. The third one is what is called as here the memory. Okay, right. So quickly we'll just discuss this and what are all this. Okay, and all these three devices. Okay, all these three devices, the microprocessor, the input output devices, and the memory devices. Okay, are going to be connected. Okay, are going to be connected through a communication path. Okay, are going to be connected through a communication path. Okay, which is going to be called as bus. Okay, right. So in detail, all this we are going to discuss. What are the different types of bus? Okay, data bus, address bus, control bus, all that we'll discuss. But just remember, all the units are going to be connected. Okay, by what is called as a communication path called as a bus. Okay, right. Now we'll just discuss one by one. Okay, first one is going to be called as the microprocessor. Okay, right. Now, as we already discussed, the microprocessor is a multi-purpose programmable devices, and it is nothing but your the CPU built on a single chip. Okay, the CPU built on a single chip is called as your microprocessor. Okay, right. Now, if you can understand, okay, so there is something that I am writing now. Okay, LSI, VLSI, SLSI. What are these? What are these actually? What are these? Anything that you can discuss? What are these? LSI, VLSI, SLSI. What is this? What is the function of this? LSI means? Yeah, tell me. LSI is? Anything that you know? VLSI at least? Yeah, tell me. Nobody knows. Huh?
Large scale integration.
Okay, large scale integration. Okay, right, correct. Okay, VLSI is?
Very large scale integration.
Okay, understood. Okay, fine. SLSI means?
Super large scale integration, sir.
Okay, okay, right. Okay, you have guessed it or typed it or checked it, whatever it is, fine. Okay, fine. Now, what is this technique? What are these techniques? Any idea? What are all this actually? So, I am discussing about microprocessor and I am telling what is called as a chip. Okay, I am telling something called as a chip. Okay, and I am discussing microprocessor and I am come across with some three terminologies. Okay, what is this actually? Now, large scale integration, very large scale integration, or super large scale integration are the techniques through which the various components, okay, various electronic components are going to be fixed onto, are going to be embedded onto a chip. Okay, if you observe a microprocessor chip, you might have observed, okay, many a times. Okay, now it might consist of so many number of capacitors. It might consist of a large number of transistors. the inductors, capacitors, resistors, etc., etc. Okay. Now, how all these are going to be embedded? Okay, how all the elements are going to be embedded onto the chip is going to be done by this particular technique. That means now, if I am going to have a microprocessor, that means all those elements, okay, all those elements in my microprocessor. So many diodes, okay, so many gates. Okay, if you remember, we have so many number of the logic gates are going to be there. All are going to be embedded onto that particular chip, and that you call it as what is called as a microprocessor. That means microprocessor is nothing but it's a clock driven device. Okay, it's a clock driven device consisting of electronic logic circuits, okay, manufactured by electronic logic circuits manufactured either by using the techniques what we have listed. Okay, now in this case, under the microprocessor, okay, we will be having what are going to be called as the various different functions. Okay, so it is called as the ALU, okay, register array and control unit. Okay, what is the function of an ALU in the microprocessor? What it does? All these are basics. Okay, you might have read somewhere. What ALU does in a microprocessor?
It
Tell me.
performs arithmetic and logical operation.
Okay, basically the arithmetic logic unit is the one which is mainly used for what? Mainly used for the computing functions. Okay, mainly used for computing function. When I say computing function, okay, it might be, as rightly pointed out, it might be the arithmetic function or it might be the logical functions. Okay, so arithmetical function includes your general addition, subtraction, all those issues. And when I come to logical functions, okay, so here we are going to use what are going to be called as the logic gates as the devices in order logic gates as the devices in order to make the decisions. Okay, so in those logic gates, I think you might have heard of what are called as the different gates which are developed by using a concept of Boolean algebra. So we have OR gate, okay, that is called as addition. Then we have what is called as the AND gate, okay, that is multiplication. Then we have what is called as NOT gate. NOT is nothing but inverse. Okay, so if I am going to give 0 as the input, I am going to get 1 as the output. If I give 1 as the input, I am going to get 0 as the output. Okay, so these are the basic gate. Then we have what are going to be called as the XOR, okay, XOR gate, okay, right, and XNOR gate, okay, right, and all those combinations are going to be there. Okay, NOR gate and what is called as NAND gate. Okay, right. So these are all the various different logic gates which are going to be present. So the basic function of the arithmetic logic unit is for computational function, okay, which is to be performed on the data that you are going to get into the microprocessor. It might be the arithmetic function or it might be the logical functions. Okay, so that is going to be the first case. Now, what is register array? What are registers? What are registers in case of second one? Okay, that is first one is ALU. That is second component. Okay, under microprocessor. Okay, let me say B. Okay, is your register array. Okay, in the diagram I wrote. Okay, register array. What are register? Any idea? In case of microprocessor, what are registers? Okay, right, in your microprocessor. Okay, now what is going to happen is, now you will be, let's assume this is going to be the whole of a microprocessor. You are going to get the data from an input device. Okay, so from input device you are going to get the data. So you have what is called as the ALU, which does certain operations. Okay, now which results in what? This operation results in some form of the mathematical output. Okay, basically in case of the microprocessor, the microprocessors are going to have what are called as register array. Okay, array is more number. Okay, array is the stream of register. Okay, right. So register array, okay, which consists of various different types of the registers, okay, which are mainly used to store the data temporarily. Okay, it is mainly used to store the data temporarily. Okay, now which data that you are going to store? The data which are done, okay, which I have got from the arithmetic logic unit. Okay, I am going to do certain operation. Those operations output is going to be stored in the register temporarily. Okay, Now, generally, in a microprocessor 8085, okay, now whatever I am talking is with respect to 8085 as per your the syllabi. Okay, right. Now we can name the register names by a letter. Okay, so the various different registers are going to be register B, C, D, E, H, and L. So these are the names of the registers which we are going to be used. Okay, so B, C, D, E is for the data register, and H and L is going to be for the address register. Okay, so just remember, in detail you will be discussing later. Okay, so now during this execution of the program, the data are going to be accessed, the data are going to be stored temporarily in the register before and after the operation. Okay, before and after the operation, it is going to be stored in the register array. Okay, right. Then third one is going to be called as the control unit. Okay, right. The control unit. Okay, what are control units basically? Now control units are nothing but, okay, basically the whole of your process. Okay, right. The whole of the program is going to be controlled, okay, by using this. Okay, it means to say that it controls the flow of data. It controls the flow of data. Okay, it controls the flow of data between microprocessor, the memory, okay, and what are called as the IO devices. Okay, now the control unit is the unit responsible for controlling flow of the data between microprocessor, memory, and input output devices. Okay, and also this provides the timing and control signal. Okay, now timing and control signals. Okay, I'll tell you what it is. Timing and control signals. Okay, right. Now what do you mean by timing and control signals is nothing but, in order to do the microprocessor operation, okay, in order to do the microprocessor operation, as I said, we have set of instructions. Okay, we have got set of instructions. Okay, so all these are the set of instructions. Now the control unit is the one which controls, okay, control unit is the one which controls the sequence of operations to be carried. Right, please understand, control unit is the one which controls the sequence of operations to be carried out and the timing at which the operations has to be done. Means the whole of the microprocessor function, okay, is going to be handled by what are called as the control unit. Okay, so that is the job of the microprocessor. Okay, right. Then that's one first component of the microprocessor formal structure. That is, the first one was the microprocessor. The second one is going to be called as what is called as the input output devices. Okay, right. So now the second one is the input output devices. So the input output devices is the one. Okay, so these are the communication to the outside world. Okay, so these devices communicates with the outside world. Okay, so whatever the operations that has to be done from the microprocessor, and the results of those operations, okay, are going to be conveniently given to the outside world through the input output devices. Okay, now these things is known things to us. The input devices, you know, it is going to be the keyboard or the switches are going to be used to transfer the binary information. Okay, now you have a hexadecimal keywords, that is 16 data keys. Okay, 0 to 9 numbers and A to F. Okay, which is the hexadecimal keyboard is going to be used with additional function keys. Okay, that is the input device. Through the input device, you are going to give a data to the microprocessor for the operation. So microprocessor does the operation, and after the operation, the output of the microprocessor has to be fed to the other devices through what is called as the output devices. Okay, now these input output devices are also called as the peripherals. Okay, so these are also called as what are called as the peripherals. Okay, input IO devices are also called as the peripherals. Okay, the output devices may be your the printer. Okay, to know very simple thing. Okay, you might have a printer output device, or you might have the XY plotter. Okay, or you might give the inputs to the cathode ray tubes. Okay, or the video screen. Okay, or your through the LEDs you can show the output of your microprocessor. Okay, all this can be considered as what are called as the output devices. Okay, now the combination of input output devices are going to be used for the collection of the data, for sending the data into the system, and for taking the data out of the system. Okay, right. That is that's about the input output devices. Okay, then we have what is called as the third one. Okay, called as the memory. Okay, right. The memory is nothing but where the information is going to be stored. Okay, so that is very known. Memory stores the information. The information may be what? The information may be a data. Okay, or the information may be the instructions. Okay, the information may be the data, or the information may be the instructions. Okay, now any type of the data, okay, is going to be present. Okay, right? Any type of the data or the instructions might be stored in the microprocessor. Okay, right. So what are the different types of memory that is going to be present? Okay, what are the different types of memory in your microprocessor? What are the different types of memory present in the microprocessor? Huh? Yeah, come on here. What are the sections of memory in the microprocessor? Okay. Okay. So what is this? What is this? What is the other one?
RAM.
Okay, right. Now, so these are the basic things. Okay, now you have two different sections of the memory. One is called the read-only memory, and another is the random access memory, or it's also called as the read-write memory. Okay, right. So the ROM is the one which you know that used to store the program. That is in the initial stage, in the manufacturer side, it is going to be done. And read-write memory or the random access memory is the one which you can able to read and alter. Okay, now this is a general observation about what is called as a memory. Okay, right. Then all these devices, okay, so all these devices are going to be communicated, are going to be connected through what is called as a communication path. Okay, so communication path, which we call it as what is called as a bus. Okay, so communication path is going to be there, called as what is called as the bus. Okay, right. Now bus is nothing but it's a information transferring agent. As simple as that. Okay, it's a information transferring agent. It transfers what? It transfers the data. Okay, right. Then it is called as the data bus. If it transfers the data, it is called as data bus. If it transfers the addresses of the instruction, okay, it is called as the address bus. Or if it transfers the control signals, if it transfer the control signal, it is called as the control bus. Okay, so broadly, okay, so these are the three different types of the buses which are going to be present. Okay, so the address bus, data bus, and the control bus. Okay, so this is something related to the formal structure of a microprocessor system. Okay, to summarize, the formal structure of microprocessor system consists broadly of three entities. Number one, microprocessor. Number two, IO devices. Number three, memory. Okay, under microprocessor, basically under microprocessor, now it's a single chip. Okay, it's all the element present on a single chip. It is called as a microprocessor. So all those elements can be present on a single chip by using the technologies called LSI, right? By using technologies called as large scale integration, very large scale integration, or super large scale integration. Okay. Under the microprocessor, the subcomponents are going to be arithmetic logic unit, which does the computational functions which are related to the arithmetic function or the logical functions. Then next is going to be your what is called as the register array. That is nothing but the data which is going to be stored. The data which are going to be present has to be stored temporarily. For that, we are going to use what are called as the registers. Okay, so registers are nothing but the entities which are used to store the data temporarily. Okay, then we have the control unit which controls the flow of the data. and the one which is responsible to make the sequential operation to be performed on the microprocessor. Okay. Then we have what are called as input output devices. Okay. So then the next is the memory. So you can have either the RAM memory, ROM, or ROM, or the RAM for the purpose of data collection. Okay. Then all these are going to be supported by what is called as, or connected by the bus, which are going to be called as data bus, address bus, or the control bus. Okay, right. So this is about the basic concepts. Okay, right. Now next we'll move on. Okay, the fourth page, right. Okay. Okay, right. Then now, after understanding the basic concept or the basic formal structure of a microprocessor, now we'll try to understand what are the basic elements as per your syllabus. So basic elements of a control system. Basic elements of a control system. Okay, right. Now, in your understanding, now I am having a basic control system. Okay, let's say a control system used to measure the temperature in a room automatically, or a control system which is going to be used to detect the presence of the water in a tank, or a control system which is going to be used to measure a fuel level in the tank. Okay, so an example I have given. So some examples of a control system. Okay, so when I say control system, are you immediately look at as the open loop control system or as closed loop control system? Which one are you going to think? I have broadly told as control system, correct? Na? I have told as control system. Okay. Now, in your knowledge, are we going to look at the open loop control system, or are we going to look at the closed loop control system? Closed loop control system, because you know that in case of open loop control system, what we don't have is, we don't have what is called as a feedback. Okay, so once there is no feedback, okay, no corrections. Okay, right, no corrections can occur. When there is no correction, okay, it is not to be used. It is not that much of a helpfulness in the actual scenario. Therefore, we are going to use what are called as the closed loop system. Okay, now in this closed loop control system, okay, so basic elements of a closed loop control system, which are the elements do you expect to be present? Just tell me, then I'll list it out. Which are the elements you expect to be present in a closed loop control system? Broadly, what you want? Tell me. What do you expect? What are the main components? What are the elements of a closed loop control system?
Feedback system.
Feedback system. Okay, right. Okay, now feedback system is for what?
For corrections.
For correction. Okay. In order to correct, what you require? Please start from the beginning. Please start from the beginning. Okay. If you want to correct, okay, what you should have?
Error.
Okay. How will you get the error?
Input.
Inputs. From where are you going to get the input? I'm asking about the elements. Okay. You are telling the parameter. Okay. I want the devices. Okay. Which are the basic elements of a control system. Now you come very closer. Okay. You will get inputs. From which device are you going to get the input?
Sensor.
Okay. Good. Okay. Now, what is the very basic element? The first element required in a control system? Because you will do all that feedback. Okay. Feedback, all that you can able to do only when you measure the parameters. Yes or no? Okay, only when you measure the parameter, you are going to do all the secondary stuffs. Okay, so first thing is what? Now I'll write. So you require the first element is going to be transducers or sensors. Okay, right. Next you tell me. I got the transducer and sensors. With this, can I control a system? With this, can I control a system?
No.
No. Okay. What else is required?
Controller.
Controller. Okay, fine. Okay, controller. Then next. Okay, next. Third one. Okay, you have got transducers or sensor.
Actuator.
Then you require controller or what is called as a processing element. Then you require what are called as the actuators. Okay. Then these are the three things which are known to us. Okay. Then we require what are called as feedback. Okay. Yeah, feedback. That is interfacing, and signal conditioning circuits. Then we require the feedback. Then we require to store all this information. We require what is called as memory. Okay, right. Now I'll just summarize. Now the basic elements of a control system is, now basically in order to make certain decision, you require certain information. Those information can be obtained by what is called as the transducers or the sensors. Then those information that you obtain, you are going to compare with the actual. Then the error is going to be generated, if at all, if there is any deviation. Then depending upon that error, you are going to make certain decision. Those are going to be called as the controllers, which are called as the processing element. Okay. Now, which is the processing element? The microprocessor. In our current study, the microprocessor is going to be considered as the processing element. Then to implement those decisions, we are going to use what are called as the actuators. Then in between the process, we require the interfacing devices and signal conditioning circuits. Okay. So interfacing and signal conditioning circuits are nothing but what? Interfacing devices is nothing but, now you require some devices for the purpose of conversion. Okay, that is D bar A converter, that is your digital to analog converter, or you may require the analog to the digital converters, or you require what are going to be called as the amplifiers. Okay, or you may require what are called as the filters, or you may require what are called as the protection devices. Okay, all this comes under what is called as the interfacing and signal conditioning circuits. Okay, now once you got all this, then you are going to have a measurement device. Okay, so remember, feedback can be done by using what is called as a measurement device. You have a measurement device from which you measure the output and gives as a feedback. Okay, right, for the purpose of comparison. Then we'll have what is called as a memory. One more very important thing, memory, to store all the information. Okay, right. These are all, maybe this might be generally asked for some 5 to 6 marks. Okay, so basic elements of a control system. Okay, right. Then we'll go further with the next topic is, just note down, 8085 microprocessor architecture. Okay, so this is an important one from the test point of view. Okay, so 8085 microprocessor architecture. Okay, so we have a small diagram. Okay, so okay, just okay, now I'll just come back now to this mode. Okay, right. Can you able to see the PPT? Yes. Okay, good. Okay, now this is what is called as here the 8085 microprocessor architecture. Okay, remember the first one, the first diagram that I had shown is the formal structure of a microprocessor. That's all. Okay, so just a formal structure of a microprocessor. Here I am trying to show you in much detail what are the various architecture of a microprocessor. Okay, now how this class is going to be, means how this chapter is going to be is, first this is generally is going to be asked for 8 to 12 marks. Okay, so this is a single question. Okay, right, with a neat block diagram explain the architecture of a microprocessor. So in that case, you will be drawing this diagram and you are going to explain briefly in 1 or 2 lines about what are the functions of the individual components. Please understand. Okay, in 1 or 2 lines, you are going to discuss what are the functions of individual components. Okay. After this, after we are done with 8085 architecture, then next study is going to be in detail about what interrupt control is. Okay. So now this as a single question you may get as block diagram of microprocessor architecture, or subsequently again a single questions you may get based on the individual components. Okay. So now whatever I am explaining now is very brief. Okay, which is for this particular particular topic only. Okay, right. Now just observe. I will just come back and show you. Okay, now observe here. So we have microprocessor architecture. Okay, right. So once you are done with, okay, so this is what you are going to do. Microprocessor architecture is what is that I am doing. Now observe introduction. I am done with microprocessor system. Okay, that is the formal structure of a microprocessor system. Then basic elements of a control system I have done. Then I am moving on to microprocessor. Okay, so once I have done with the microprocessor, then I am going to come back to microcontroller. Okay, so this should be in the sequential order. Microcontroller should be studied only after you know the microprocessor. Okay, right. So that's why from here I am going to microprocessor architecture. So this is the broadly I am going to discuss. Then in detail we are going to discuss the individual components. Okay, right. So as of now, this is going to be your microprocessor architecture. Okay, right. Now just observe for your understanding. Okay, right. So this is wherever I am writing the 2 lines. Okay, so that is nothing but the path. Okay, that is nothing but the path. Now if the path is going to have 2 arrows, okay, it means you are taking the data, means data bus is what? You can give the information to the data bus and also you can retrieve the information. Means both the ways. Okay, it means both the ways. Data, therefore, by data bus is what? Is it unidirectional or bidirectional?
Bidirectional.
Bidirectional, simple. Okay, data bus is a bidirectional. Okay, so any data can be fed to the data bus and anything I can take it out from the data bus. Okay, right. Now to start with, okay, so these are all the entities which are going to be present. Okay, now interrupt control unit. Okay, right. Then serial input output control unit. These are all the register that I have told. Register B, C, D, E, H, and L. All these are called as temporary register. Then stack pointer register, that is SP register. Then program counter register, that is PC register. Then incrementer or decrementer, instruction register, instruction decoder, temporary registers, accumulator, flag register, arithmetic logic unit, timing and control unit. Okay, now this is about the architecture. Briefly, I will just explain what is the internal architecture of 8085. Okay, now before that, what for it is, first of all. Okay, so the architecture of 8085 is capable of performing the following operations. Okay, now this is what for 8085. 8085 is to store 8-bit data. Okay, now as I told, I am doing as per the syllabus. The syllabus states it is 8085 microprocessor. Now gone are the days where you are dealing with 8-bit data. Okay, so this is the old story. Okay, but as far as the syllabus is concerned, I am just doing this. Okay, now currently you are having 64-bit data, all that is running. Okay, and dual core processor, all that is running. Now concerned to this, I am talking. Okay, concerned to 8085, so it is used to store 8-bit data. Okay, right, which is going to be in the form of registers or the accumulator, and it performs arithmetic and logic operations. The one which performs that is called as ALU, and it sequences the execution of instruction. Which unit is going to sequence the execution of instructions? Which unit is going to sequence the execution of instruction in the microprocessor?
ALU.
No. ALU is before. ALU is done already. Which is going to sequence the execution of instruction. ALU performs the operation. Okay. ALU is going to do the operation, which is going to say what operation to be done after what. If you remember, we have discussed what are called as control unit. Okay, so in the formal structure there were 3 things. One was the microprocessor, second one was input output devices. Okay, so under microprocessor 3 things we have discussed. One is the register array. Next one, first one is arithmetic logic unit. Second one was register array. Third one was control unit. Okay. The control unit is the one which is going to be used to sequence the execution of instruction. Okay. Then last one is memory. That is nothing but store temporary data in RAM during the execution. Okay. Right. So this is the operation which is going to be done. Now, one by one, we'll try to understand. Okay. Right. Now, just observe here. Here, what is called as the arithmetic logic unit here. Okay. Now, this is the diagram. Okay. Right. It may take some time. Okay. Just observe. Okay. And I'll just pass it on to you. Right. One by one, we'll write down we'll understand the operation. First one, arithmetic logic unit. Okay. What ALU does? ALU performs mathematical operations has been indicated here. Okay. That is the computational operation it's going to do, addition, subtraction, comparison, and all that. And along with that, it performs the logical operations, okay, using logic functions. Okay, so that is very important because you are dealing with what is called as binary data. Okay, so manipulation of the binary numbers is very much required in order to build the circuit. Okay, so manipulation of binary numbers is what I will have 1 plus 0 plus 0. Okay, I want to do arithmetic addition of binary data. So arithmetic addition of binary data is done by using OR logic gate, OR logic gate. Okay, so multiplication is done by AND. Okay, right, and inverse is going to be done by NOT gate. Okay, so you might have observed these different gates. Then after this, you have the NOR and NAND gates. Okay, and then NOR and XOR and XNOR gates are going to be there. Okay, now all those are going to be done by using the arithmetic logic unit. Okay, so the arithmetic logic unit does this particular purpose. Then next are called the temporary register. Okay, which are the temporary register? Now, if you observe here, this is a temporary register. So these are also called as the temporary registers. Okay, right? Are the register arrays. Okay, what are temporary registers? So if you want to store the data temporarily, that is the arithmetic logic unit, after it does the operation, I need to store the data temporarily. Those data are going to be called as the temporary are stored in temporary register. Okay, then we have an accumulator. Okay, you know the accumulator. Basically, accumulator is a single 8-bit register that holds the results of any operation. Okay, so immediately after the operation, that data is going to be stored in what is called as an accumulator. Okay, then we have decoder. Decoder decodes the instruction from instruction register and activates the timing and control unit. Okay, just observe now. Okay, right. Now, now just observe. Now, temporary register, accumulator we are done. Okay, then we have instruction register. Okay, instruction register, what it does, from the data bus, I am going to retrieve. Okay, I am not giving it back to data bus. Remember, instructions are going to be taken from the data bus that is stored in the instruction register. Instruction decoder will decode the instruction. Okay, so simple thing. Okay, so instruction register, an example of instruction register is add A, B. Okay, ADD add. Okay, then space A, then B. What does it mean? That is a line. Okay, that is a microprocessor programming line. Okay, what it says? So it is telling add two data, that is A and B. The question is the microprocessor understands that language is the one. Okay, whatever the program that you are going to write, it will never going to be understood by the machine. Okay, so that is what you are going to write is a user level language that has to be converted into the machine level language. Okay, so now that is going to be done by the instruction decoder. Instruction decoder decodes the instruction which is to be understandable by the microprocessor, and that will be given to what? Timing and control unit. Because remember, timing and control unit is the one which drives or which controls the program. Okay, timing and control unit is the one which controls the program. Okay, so that is the meaning of this third one. That is decoder decodes the instructions from the instruction register and activates the timing and control unit. Okay, right. Then what timing and control unit is going to do? Now you just observe, it determines the timing and sequence of operations. Okay, it determines the timing and sequence of operation. It generates the timing signals used to fetch the program instruction. Okay, Now this unit controls the entire operations of a microprocessor system. Okay, so timing and control unit is the one which is going to be used to control the whole of the operations. Okay, then we have a general purpose register. So as I mentioned, okay, so 6 general purpose registers are going to be there, like B, C, D, E, H, and L. So all of them individually are 8-bit register. Okay, B is a 8-bit register, C is also 8-bit register. Okay, if you want to use them as a pair, okay, register pair, so the combination, the valid register pairs are going to be BC, DE, and HL. The valid register pairs are, you can't merge B to D and C to E. Okay, you have to go with BC, DE, and HL. So those are the valid register pairs to do a 16-bit operations. Okay, right. Then we have what is called as a PC register, which is called as the program counter register. Okay, right. So this basically, okay, which is program PC register, is a register used to control the sequencing of the program. Okay, that means in where exactly the program is going to be running, whether it is in the first line or whether it is in the 5th line or in the 8th line, like that. Okay, in order to understand that, we are going to use what are called as the PC register. Then stack pointer register, okay, that is SP register. So stack pointer register is the one, okay, which forms the address which defines the top of the stack. Okay, that means if there is going to be what is called as the RAM is going to be there, the RAM is going to have so many compartments are going to be there. The top compartment address is going to be present in this stack pointer register. Okay, so in detail we'll discuss all that. Okay, right. Then so the input of the data to the microprocessor is going to be through the SID, that is serial input data, and the output of the microprocessor will go through what is called as SOD, that is serial output data. That means to the microprocessor, information comes from SID and information goes out from SOD. Okay, so that is what we need to understand. Okay, then we have what are called as the bus. Okay, so as I mentioned, the bus is nothing but a group of wires used for the communication. Okay, so just remember that, and we'll come back. Okay, right. So this is something related to. Okay, now I just don't want to take much time. Okay. Now, this is something related to what is called as the 8085 microprocessor architecture. Okay, so tomorrow we'll just come back and we'll just go through with some more details of the 8085 architecture. Okay, I think at this point I'll just stop. Okay, so now please type your USA number. Okay, on the chat box. Okay, for my attendance. Okay, right. So please type your USA number. Please type your USA number on the chat box. Okay, or else once again, okay, if you are going to be there, just Abdul Khalid Pasha.
Present, sir. Yes, sir.
1 second. Okay, I'll just finish it off now itself. Okay, Pasha.
Present, sir.
Anil Kumar, Master.
Present, sir.
Ankesh Aman. Ankesh. Okay. Basuraj Avatigar. Basuraj.
Yes, sir.
Yeah. Chandan KN. Chandan. Chetan Kumar DK.
Present, sir.
Yeah. Dheeraj.
Present, sir.
Dheeraj.
Present, sir.
Yeah. Got it. Himanka. Yeah. Himanka present. Okay. Murali Kishan. Kunal.
Present, sir.
Yeah. Dhanush. Dhanush. Okay. Naga Murali Kishan. Okay. Fine. Kunal.
Present, sir.
Yeah. Sorry. Dhanush. 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 Junaid. Yeah. Why Junaid, you are not can't speak, huh? Shri Prasad.
Yes, sir.
Niharika.
Yes, sir.
Nihar Venkat Sai.
Yes, sir.
Nilesh.
Present, sir.
Nirav.
Yes, sir.
Prajwal R. Patil. Prince. Prajwal or Patil present. Okay. Prince? Prince Tongor? Rishabh Pandey?
Present, sir.
Rohan?
Sir, present.
Rohan present. Okay.
Sir, present.
Yeah. Roshan?
Sir, present.
Sagar GV? Sagar?
Present, sir.
Yeah.
Present, sir.
Yeah. Sharanaya?
Yes, sir.
Yeah. Sheikh Mandan?
Present, sir.
Yeah. Shobit?
Present, sir.
Siddharth Shankar? Siddharth? Yeah. You're there. Siddharth Sridhar?
Sir.
Siddharth Sridhar? Yeah.
Yes, sir.
Subramania?
Present, sir.
Yeah. Sumak? Ullas?
Present, sir.
Yeah. Vivian?
Present, sir.
Pawan?
Present, sir.
Shiv Krishna? Yeah, present. Okay. Ranveer Singh Chauhan? Okay, not there. Okay. Dhanush Natampalli?
Present, sir.
Yeah. Gautam Sai?
Present, sir.
Gautam?
Present, sir.
Yeah. Chanakya? Chanakya is not there. Simika?
Present, sir.
Shiva Pavan?
Present, sir.
Yeah. Okay. So I've done with. Okay. Right. Thank you all.
Excuse me, sir.
Thank you, sir.
Yeah. Tell me.
Sir, yesterday you had sent a link to all the for a company who's providing us internships, sir. So I just wanted to inquire about that. So can I speak to you for 2 minutes, sir?
One second.
Yes, sir.